Hi, Amy. How are
Hi,
you
sir.
doing? How
I'm
are you
good,
doing?
thank you. How are you?
Good, good.
That's good.
So, how's your school going on?
Yeah, good. Just got a lot of tests coming up, so like revising for that.
Okay, that's good. Okay.
Yeah.
How about mathematics?
Yeah, there's a maths test coming up, like a baseline thing. So yeah,
Right.
in a week. Yeah,
In a
in a
week.
week.
Okay. Okay. So, in that baseline, what all will you be covering?
Um, oh, I did send you. It was like straight line graphs, a few algebraic expression stuff like index laws, surds, and then like quadratic functions, simultaneous equations and stuff.
Okay. So, what we can do is that one by one, we can pick up a topic and have some questions based on those topics.
All
That
right.
we can review. Let me take today quadratic functions, right? So, I prepared
Okay.
some, questions for you. So let's see if you are ready to solve them. So let me just share my screen and then we'll see. Okay, so I mean, here are about 10 questions for you. So let's see how much you remember. We did go through quadratic functions earlier, but that was long time back. Now,
Mm,
these are the 10 questions which I thought will cover up almost everything in quadratic functions for you. The
all
first
right.
one here is to isolate variable from the equation s equals to ut plus half at square. This is not a very simple question because there are two t's involved in this particular equation, so it's going to be slightly tricky.
Mm,
The second one is write the transformation of the function y equals to 2x squared minus 6x plus 1. Here again, this is not given you in the vertex form. If you have equation in vertex form, you can easily write down the transformation, correct?
right.
In question number 3, show that the solution of equation ax squared plus 2bx plus c equals to 0 is x equals to minus b plus minus square root of b squared minus 4ac upon a. Now, this is kind of a derivation of your quadratic formula, and we'll see and understand how to go about. Question number 4 is, show that x squared minus 6x plus 10 is always positive. 5. Factor fully 14x to the power of 4 minus 13x squared plus 9, 6. The product of two consecutive integers increased by their sum is 98. Find the possible integers. A simple word problem which could be complicated at times. 7. Line y equals to 10 intersects parabola y equals to x minus 2 whole square plus 1 at A and B. Find the area of the triangle ABC. Now, that is the type of question which is normally asked in GCSE test paper. Question number
All
8.
right.
Yeah, this is very critical. Question 8. In fact, these questions which we are not talking about are from related to your test papers, which are expected in GCSE level AAS. The equation y equals to 2x squared plus ax plus 23 can be written as y equals to x minus 3 whole square plus b. Find the value of constants a and b. Question 8 is, find the range of values of k for which the equation kx squared plus 2kx equals to 8x minus k has two distinct roots. So you need to analyze the discriminant, right? Question number 10. One of the x-intercepts of the graph of y equals to 3x to the power of 2 over 3 minus 5x to the power of 1 over 3 plus k at x equals to 1. Find the other x-intercept. Very interesting question. Looking at it, you will see, well, this is not a quadratic equation. But well, if you replace x with, yeah, x to the power of 1 over 3 with some other number, it does represent a quadratic function, correct?
Yeah.
So now let's look into their solutions. Can you tell me the approach which you are going to follow for solving the very first question?
I was going to like take t out, but obviously there'll be t in the bracket.
Yeah.
So yeah, so let's just move on.
Okay.
I don't really know how to do that.
Yeah, that's a very difficult question actually, because normally when you are
Yeah.
isolating variables, things are much simpler. But since we are talking about quadratic functions, I thought let me take this. And this is, a very standard equation which you land up in the very first chapter in physics, correct? So
Right.
we'll isolate from this particular equation. S normally is the displacement, U is the initial velocity, T is the time, A is the acceleration due to gravity. And so we normally use this formula some way or the other in kinematics. So what we are going to do here is write this in the vertex form. So we'll follow the steps which should be used for completing the squares. Once we complete the squares, we are in a position to isolate it, otherwise not, right? So let's be very clear about it. So while we go through these process, also there'll be a review for you how to actually complete the squares. So the coefficient of the leading coefficient here is half, you can see here. So I reorganized the equation and took half common, right? So half A rather, because A is also part of your coefficient. T is the variable in this case. So when you take half A common, you're left with T square plus 2 over A ut. Now, so let me rewrite this first in the term like half becomes simpler plus ut, correct? Now you can correlate. So the first term, when you take half A common, you are left with T square. In the second term, because 2 is in the denominator, that goes up. So 2 over A times ut, right? So that is what you get as the second term. To complete the squares, we have to take half of the coefficient of T now and square
Right.
it. So when you do half of this, it becomes u over A. So you square it, add and subtract the square of half of the coefficient of T. Once you do that, then in that case, the first three terms, which are these, they form a perfect square. And you could write them as T plus u over A whole square, and the other term, which is a constant in this case, u square over A square. You could open this bracket also. Now, when you continue, just open the bracket, multiply both these terms by applying the distributive property, correct? So open the bracket. So once you open the bracket, you get half A T plus u over A whole square minus half A u over A whole square. Now you can isolate the two terms clearly, and we have this vertex form. You can bring down the other term, which is half u square over A, which does not involve T, to the other side. So you get half of A, T plus u over A whole square equals to S plus half of u square over A, right? A lot of steps. Now you multiply, you can do cross multiplication. So on both sides, we multiplied by 2 over A. So multiply by 2 over A on both the sides. Now you're left with T plus UA over whole square. And then you square root. Remember, whenever you square root, you have to do plus and minus. And now bring the other term and you can isolate T as shown here. So that is how you can isolate T. So a lot of steps involved. How do you like it?
Yeah, it's just getting the first part of knowing that it's completing the square in order to solve the problem.
Yes.
But then as you go through, it's really straightforward. I prefer your method of, like adding the square, subtracting the square, because I already showed you like my teacher's methods and the ones we do at school, and it gets really confusing. But this one, honestly, like works all the time. So yeah.
Okay, great. So once you understood this, actually this question covers many different types of questions, since we also learned the process of completing the squares, and that helps many questions related to finding maximum or minimum. And that's the reason why in the set of 10 which I have included, I didn't include any question on those kinds of optimization questions.
Oh,
And the
right.
steps will be
Yeah.
simple, right? Because so I cut down on those questions. Here we'll look into transformation, and again, when you do the transformation, you have to repeat the same process, that is to complete the squares. So we need to transform the function y equals to 2x squared minus 6x plus 1. So Amy, now can you tell me how will you write the function to explain the transformation of this equation in standard form?
Okay. So like you said, we need to complete the square.
Yes.
So we can start by that. So we do 2x squared minus 6x equals minus 1. Oh, but
That's the equation.
it works the same. Yeah, but I was gonna do your method of
We are not
moving
solving the equation. We are just keeping the equation as such, and then the
Oh,
term which is on the right side will complete the square.
all right, okay. So, oh yeah, I get what you. Okay, yeah. So yeah, so you just keep take the x squared minus 3x, put it into because you have to take the 2 out, and then do x squared minus 3x, and then minus 3 because that's the coefficient of x. We have to divide that by 2, square it, and then subtract it, and then brackets again.
Yes.
Plus 1. We use the square brackets because we've got the brackets inside, so you want to keep them separate.
Good point.
Then you do x minus 3 whole squared minus 9 over 4, which is the 3 over 2 whole squared, and then brackets again plus 1. Then we remove the brackets, we multiply everything by 2, so we get 2x minus 3 over 2 whole squared, and then minus 9 over 2 plus 1. Then you do y equals to 2x minus 3 over 2 whole squared, and then you just do minus 9 over 2 plus 1. You can do it obviously by hand or using a calculator if you have one. And then you get y equals to x minus 3 over 2 whole squared minus 7 over 2.
Perfect. Now, can you
So,
explain the transformation?
yeah, so I mean, I would start by doing just a little quick sketch just so I can get an idea in my head.
Correct.
So we know the turning point's at 3 over 2 and minus 7 over 2. And then we know the intercept is at, oh, well, you just sub in x is 0 into the equation and find out your y-intercept, and then just quickly do a rough sketch. Then what we learn from that form, we know that so the horizontal translation, so it moves right 3 over 2 units. Yeah. It moves vertically down 7 over 2 units. And the big 2 in the front is it's the vertical stretch, isn't it? Like,
yes.
Gets times by 2, I think, by a factor of 2.
Okay.
Yeah.
So whenever you explain transformation, you have to always explain in the correct order. That is very important. So order means you have to do multiplication
Mine was
first.
all over the place. Yeah.
No, only thing is you didn't start with the stretch. So order, you can always perfect if you go from left to right. So remember that part. So when you want to do, you do left to right. Got it. So when you go from left to right, the first number which you hit is 2. So first number should be 2. So therefore I wrote here vertical stretch by a factor of 2. Writing a factor is very important since you're multiplying by it, right? So
Yeah.
vertical stretch by a factor of 2. The next number which you hit is inside, which in this case is minus that 3 over 2. And that means horizontal translation 3 by 2 to the right. And then what we get to is the vertical translation 7 by 2 units down, right? So that is the sequence. You can, of course, combine these two, write them in a straight line, saying translate 3 by 2 units to the right and 7 by 2 units to down. But important part here is you have to go for stretches, I should write, compressions and stretches, and reflections. So that is first. And second step is translation.
Oh, okay.
So when you are talking about the stretches, it could be horizontal or vertical, both, right? So first describe all the stretches, compressions, and reflections, and then go for translation. Clear?
Oh, okay. Yeah.
And that is how you're going to sketch your function also. If they want you to show all the transformations from the parent function y equals to x squared in this particular case, right?
Wow.
Okay, so let's move on to the next question, which is show that the solution of the equation ax squared plus 2bx plus c equals to 0 is x equals to that. Now, tell me, how will you do this question?
Yeah, so I had a similar question to this, and I sent it to you on WhatsApp, and then you replied.
Yeah.
And because I found it quite tricky with the whole C thing, you were like, just move it away completely.
Correct.
So it's the same process, but I just move initially in the beginning. I just take the plus
Let's
C
go with
and
your
just move
process.
it onto the.
Let's go with your
Are you
process.
sure?
Yes.
Okay. It's not that different, but like it's your process, but like it's what I prefer.
Tell me.
So ax squared plus 2bx equals minus c.
So you brought it to the other side so that you're not really confused with C, right? It doesn't really play a role of completing the square. So you prefer to keep it away and far away, right? That's a good thing.
Right.
Then next step.
Then I take a outside. So you get x squared plus 2b over a x, equals minus c. Then we kind of do the same steps. So we do x squared and we do half of 2b over a, which is b over a. So you add b over a whole squared and you subtract b over a whole squared equals, bracket again, equals minus c.
Okay.
Then
minus b over c.
Minus, yeah.
Yeah. Correct. So exactly the same steps, but you brought c to the other side. That's what you did, right? Okay.
Right.
So we'll continue with what is written here, thinking that c is already on this side, correct? That's what you did.
Yeah.
Perfect. Which I did at this stage, as you can see, right? So basically, you brought the c right on that side, and then you were at this stage, and then the process is similar, right? That's what you're trying to say. Perfect. And that's a good approach.
Right.
I mean, I really prefer that particular approach, keeping C on the right side and then continuing with your process, which you had, and, you know, kind of like this. But at this stage, we come at the same point, right? Because you really isolate. And that is how you could isolate and get the formula as shown here. Perfect. So that becomes...
It's a nice clean layout.
Yes, it is.
Like it's clear. It's like not like as if like the C is moved completely, then you know you're only dealing with the X stuff on one side because the constant is moved, like literally out of the way. So it's really good. Yeah.
Agreed. Okay. Next question here is question number 4. Can you please read the question and explain the solution?
Yeah. So question 4, show that x squared minus 6x plus 10 is always positive. So I can see that you've done completing the square, but I would have done, I don't know if this is right, but I would have done, I would have used the discriminant and then just done b, so I would have done b squared minus 4ac.
Okay.
I'll sub in the values.
Okay.
And see like what the outcome is. If it's greater than 0, equal to 0.
Okay, so you do that, and then you write b squared, which is 6 squared, right? So which is 36 minus 4 times
minus
a is 1 and c is 10, correct? And what you get here is minus 4. Then
so since minus 4 so since minus 4 is less than 0, we know it doesn't intersect with the x-axis, so therefore it's always positive. Is that an explanation, or is that not enough?
Okay, there is one problem with this, and that is, with this you can surely say that there are no real roots. That is what you can say. But I could have a parabola kind of like this, where again we don't have any real roots. Do you see that part? The question here is always positive, right?
And that's negative.
It could be, right? It is possible. Now,
if it's on,
but we could justify with your solution also. You know why? You can say when x is 0, then the value is 10. That means the function is positive for x equals to 0, right? And we know that it has no real roots. And therefore, and you can also say that the function opens upwards, right? So you have to
Yeah.
justify in so many different ways. And your
Oh,
statement,
so don't just leave it like that.
no, you can't leave it like that.
That's wrong. Yeah,
That is
got it.
half the solution, because
Mhm.
it is possible that it could go down, right? So if you say this function
Right.
opens upwards, then definitely that is not the case, right? You can say no real
Mhm.
roots, and as the function opens upwards, it is always positive. You get the idea.
Oh,
You
okay,
could
yeah.
also say no real roots, but for x, the value y-intercept is 10, so it has a positive value. So it cannot be that case. You could say like that. And then
Oh,
you have
I
to
see.
justify.
Yeah,
You have to justify. Okay? So that's a good,
makes sense.
yes. Completing the squares is probably the easiest way for a simple example like this. This is relatively a simple example. But anyway, when we are talking about the methods, let me teach you another method, which we call as partial factoring. Do you know what is partial factoring?
No.
Okay.
Well,
Now,
factoring partially.
yes,
I don't know.
factoring partially. So what we do here is we have got x squared minus 6x plus 10. So that means I could just factor x. I will not do full factoring. So I get x minus 6 plus 10, right? It really means that when x equals to 0 or when x equals to 6, what is the value of y? Y is 10.
10.
So at 10, if you draw a line, for example, this is only to explain you the concept of partial factoring. It will intersect at 2 points. One is at x equals to 0. The other one is at x equals to 6, correct? Because at these 2 points, y value will be 0, right? You can see from the
Right.
partial factored form. Now, where is the axis? Axis is midway between the two, correct? Which is at 6 by 2, which is equal to 3. So we know that the axis is at x equals to 3. And therefore, the vertex will also be at x equals to 3. So substitute 3 here. So we get 3 squared minus 6 times 3 plus 10, which is 9 minus 18 plus 10. And that gives you plus 1, correct?
1. Mm-hmm.
So we have actually partially factored, and we know this is a parabola which opens up, right? So we can always say it opens up. Let me just push the page a bit so that I could write more information here. So we already have the case. We know this is not the case. Let's remove this, that this parabola opens up, right? And the minimum is at 3, 1. So therefore, that is always positive, right? So opens up with minimum value of 1, right? Therefore, always positive.
Oh, okay.
Greater than or equal to 1, correct? So we could justify that without doing completing the squares. That's what I'm trying to say, because we found the
Oh,
vertex. By completing the square also, we are saying the same thing, right? We are saying that the vertex is at 1, 3, right?
mm-hmm.
We said the same thing. The vertex is at, say, 1, 3, and the parabola opens upwards. Therefore, the minimum value is 1. Now, to find the value of the vertex, we could also use the method of partial factoring. Do you see that part? So, partial factoring, you can do it in
Yeah.
steps always, howsoever complicated the equation is. You get
All
the
right. Okay. Yeah.
completing the squares, as
So,
we have done in previous examples, could take a lot of time. Do you see completing the
right.
squares method?
Yeah. It's when it has like letters and things in it, it takes longer.
Correct.
Yeah.
So we'll actually see also how to actually solve optimization questions using partial factoring. Okay, you like this method?
Oh, yeah, I
You
do.
could actually
So,
substitute. Yeah,
yeah, so what I was just saying from this slide, what I learned is partial factoring and how you have to actually justify your answer. Like, don't just state one thing, you have to
correct.
add so that there won't be any contradictions to it.
Yes, you have to add. So
Mhm.
even in this question, if you follow the standard method as we did, we have explained. You see this? Can you
You
please read?
still have to explain, yeah.
Can you please read this?
This is, yeah, so this is a parabola which opens upwards from the vertex 3, 1. The minimum value of this function is 1, therefore it is always positive.
Correct. You have to justify it. You would always say always positive greater than equal to 1. You could add that. Sometimes we can also change the question and ask for the range. So you can say the range is greater than equal to 1. Okay?
Oh.
Yeah. So many different
Lots
ways of
of,
asking the same thing.
yeah.
Next question here is one of the very difficult questions to factor. So we need to factor 4x to the power of 4 minus 13x squared plus 9. Can you tell me how will you factor this?
I mean, I do remember like you doing this once, but you make y equals, since the lowest like exponent, let's say, is x squared, I would make, let's just say, another variable y equal to x squared.
Okay.
That means y squared equals x to the power of 4, and then I'll just sub it in to the equation. So 4y squared minus 13y plus 9.
Right. And
But
then
I don't know where to go from there. I know it's simple, but like so when you try it, so how would you do that though?
Okay.
Would you use minus b?
Yeah, we can go your way. Since we want to make a perfect square, now from here, look at it. We want to factorize this. So as far as this is concerned, 9 times 4 is 36, correct? 9 times 4 is 36. And we need a product of 36, and we need a sum of 13. I know that is minus 13. So let me write like this. We need product P and Q of 36, and we need a sum of minus 13, right?
Oh,
Yes.
9, minus 9 and minus 4.
Okay, so minus 9 and minus 4 can work for you. And therefore, we can write this as minus 9 and minus 4, and we can then further continue this. So we get 4y squared minus, let me write 4 first, because 4 will match with this, right?
Yeah.
Minus 9y plus 9. And then here, you can take common 4y, and so you get y minus 1. And here you take minus common, you get 9 common, y minus 1. And now you can take y minus 1 times 4y minus
9.
9. Correct. So you have factored it. Now you know that y is x squared. So substitute back x squared into this. So you get x squared minus 1 times 4x squared minus 9. Now both of them are perfect squares. So you could write this as x plus 1 times x minus 1 times
X minus 1.
2x plus 3
2x plus 3
times 2x minus 3. Is that correct?
Awesome. That's a nice question.
So you got it.
Perfect squares.
You got the same answer by substitution, and indeed your method is better.
Could you explain your method though, just so that I have,
Same method.
alternative?
Yeah, it is the same method which I have used. Only thing is, I kept x squared as x squared and x to the power of 4 as x to the power of 4. Because for me, like, these numbers are very convenient. They're not so confusing. So I just kept them like this. Now, I did this perfect square thing in this particular case. I actually did, oh, I see. I changed my method here. Okay. Wow.
Oh.
Okay. So this is a different method. So I adopted the method of completing squares. We normally use this method when we have something like unfactorable. So that is the kind of method which we use. So what I realized was that 9 is a perfect square and 4x to the power of 4 is also a perfect square. To get perfect square now, I need the center term, which should be 2ab. You understand 2ab? 2 times 2x squared times 9. That's what I'm looking for. The center terms.
Oh, yeah. Sorry. Yeah, just got it.
You get my point, right? So
Yeah.
that's what I'm looking for. So what I did was that 2 times, let's say 2 times 2x squared times 3 is what? 4 times 3 is 12, right? 12x squared, correct?
Yeah.
So split 13 into 2 components, 12x squared and x squared. You get the idea?
Oh.
Because I have a perfect square now. So I split 13x square into two components, which were 12x square and x square. Now I combine these three, correct? So let me just highlight in a different way. So first step you understood, right?
Yeah.
Now,
Yeah.
because I was working on these numbers. So if you look into these three, they actually form a perfect square. And that was the whole thing. And which is 2x square minus 3 whole square. And I got a minus x square term on the side.
Mm. All right. Yeah.
I've used a square minus b square is equals to a plus b times a minus b. So I have difference of squares at this stage, right? Difference of squares.
Yep.
So I have difference of squares, so I factor it. A plus b times a minus b. Rather, I wrote a minus b plus times a plus b. And then both individually could be factored using factoration process, and then we got the answer.
Makes sense. Yeah.
It is complicated. It is more complicated. So your method in this particular scenario works better.
Yeah, but like you said, if you get to the unfactorable questions, you need to use your one because it's harder. Yeah.
That is true. So yeah, so I took this method mainly so that I could teach you one more method. And fortunately, you gave me the opportunity by telling a better method, which should be used in this particular case. I really appreciate that. So you are right on there. You're well set for your math. Good performance. Good job. Now, question number 6. Can you please read this question and tell me how will you do it?
Right. So the product of two consecutive even integers increased by their sum is 98. Find the possible integers.
Yes. How will you solve?
All right. So when I'm thinking two consecutive integers.
Even integers.
Yes. Yeah. So does that mean like 2n and then 2n plus 2?
That's too complicated.
Oh.
Yes, it means this. You are right. Why not just take one value n and another as n plus 2? Well, they could be both odd also.
Oh,
yeah. They could be both odd. They could be both even because we are saying n and n plus 2. But the question is so designed for you. The product of two consecutive even integers increased by their sum is 98. So ultimately, you will get some answer. And if the question is right, you will get the right answer, correct? So we'll not complicate it. we'll not take that case, which is also correct. But we'll make it simple, right? Which is, let's just take one variable as x and the other one as x plus 2, as I did here, right? Of course, you have to skip a number to get consecutive even integers. So don't take x and x plus 1 for sure. Is that okay?
So, it's because I thought because with x, like you said, it could be odd.
Yes, it could be odd. So when you find
that's why I thought you had to specify 2n.
No. So the thing is, see, let us say if you get an odd answer, right? We are looking for even numbers, correct? We'll say something is wrong, correct? We may redo it. But if we get even, then we are correct. Does it make sense to you?
Oh, you're saying, okay. That's what the whole thing in the beginning was about. Okay, yeah, got it.
Yeah. Why should I complicate my solution, right? On the assumption that I may have so many different stories coming up, right?
Can you do that though in the exam?
Yes. So it
says, won't the examiner be like, the x could be odd?
Yeah.
And then how do you justify it?
No, we are not justifying. It says, find the possible integers. We are finding the possible integers. We don't have to justify our variable, correct? The question is not about asking you that how will you define an even integer, you understand? Or two consecutive even integers. The question is not that. The question is to find even integers, and if you don't get, you can go back and check, do rework.
Oh, okay. Yeah.
But keep it simple.
That's right.
So keep it simple is the key, okay? Don't complicate.
Okay.
The question paper is going to be very complicated as such. So simplify wherever you can. So now, The equation is okay because we are saying product and then the sum of these two is 98. Then it's a simple solution. You can always factor this and then get the solution, right? Now here, Amy, sometimes we are dealing with big numbers like 96. How do we get product and sum? So at this stage also, I prefer to split my numbers and factor them so that, we can get to know how do we select 12 and 8 as our answers, right? That's the whole thing.
Mm.
So you could do like this, that, well, 96, what is half of 90? Let's try to prime factorize it to get the possible factors to work with, right? So 2 times 4, 48, and then we can say, well, this will be what, 24? And then this could be, you can say 2 times
6 and
6
4.
and 2 times 3. So now we know that we have to work with all these numbers, which are so many 2's and a 3, so that,
You meant
so that we get a sum of
12.
Is that clear?
So the 24 splits into like 2 and 12 or something, or
Yeah.
6 and 4.
So
You
now
put 2 and 6.
if I do this, 12, pardon?
24 splits into 2 and like 12, or
Oh, that's why I
6
missed
and
one.
4.
Right, you're right.
Yeah.
24 splits into 12, and then we get 2 and 6, and then 2 and 3, correct.
Yeah.
And so what you get here is, now you can combine your terms and you can say, well, these gives you 12, and that gives you the other set of 8, and that can work for you as a difference of 4, right? You get the idea. So it becomes, this factoring thing becomes very handy, especially when calculator is not allowed and the numbers are big.
Yeah.
So 96 and 4 is still less than 100, so it is okay for time being. Okay. Let's take another example, and this one is a very interesting question. Can you please read the question, Nami?
Yeah. So line y equals 10 intersects the parabola y equals x minus 2 whole squared plus 1 at A and B. Find the area of the triangle ABC, where C is the vertex of the parabola.
Correct. So basically, as you can see from the diagram, we have line y equals to 10, which basically is a horizontal line. Intersects a parabola which is opening upwards with the vertex, which is at 1 and 2, and you find the 2 points where it intersects. Clear. Now it says find the area of the triangle ABC, where C is the vertex of the parabola. So straightforward question. To find these 2 points, what you can do is just substitute 10 and find the value of x, right? So you get these
Right.
x values. Once you have these x values, you can know the base. This gives you the base, right, of the triangle.
Yeah.
And the height is here. Height is this, y value, difference of y value, delta y. Correct? 10 minus 1. Correct? So area of the triangle is half base into height. You can clearly find the area of the triangle as shown here. Perfect. So in such a question, first thing is make a rough sketch. Once you make a rough sketch, you have a clear idea as what we are going to do. And then you can see, well, the horizontal line is going to cut at 2 points, right? So just substitute 10 there and find those 2 points. Those 2 points are at x equals to 1, minus 1, and 5. So this is minus 1, that is 5. Now the triangle formed is shown in red here. The x value difference gives you the base of this particular triangle, which is 5 minus minus 1. That gives you 6, the base of the triangle. The height of the triangle is from the vertex to the line, which is 10 minus 1, which is 9. And the area of the triangle is half base into height. And then write down your answer, 27 units square in this particular case. Clear?
Yep.
In your test, there could be a line which is not really like this, right? It could be y equals to something else, right? For example, x plus 1. In that case, we may have a line which will be going something like this, correct? So then again, you can find a triangle and solve in a similar fashion.
Oh, okay, yeah. So it doesn't matter whether it's like a right angle triangle or this.
Okay. So
How do you know?
Okay, let's do this part. Okay, that's a good question. So, yeah, if it is not a right, okay, that's a good question. So if it is not a right angle triangle, let me just sketch one parabola here and let me draw a line, something like this. Is that clear to you? Now we are actually
Yep.
interested in the triangle whose vertex making this type of a connection, correct? That is your triangle now. And in this particular case, what you can do here is basically look into, in this particular case, from the vertex, we may have to find the height of the triangle. As drawn here, in this particular case, ME, you may have to find the line perpendicular from the vertex and then this point and the distance. So,
You're looking at like that with the red line being the base.
yes, red line being the base.
Oh.
If you get in this form, in that case, there is no other option than to find the height of the triangle using the concept that your line is perpendicular, right? So you find slope m here, and the slope of this will be -1 over m. So you find the equation, and then the point where this perpendicular line intersects the given line. And once you find that height, then you find the area. So it becomes complicated, right? So yes.
How do you, so do you assume, so do you always find the height, and then would that tell you whether the triangle is isosceles, scalene, or whatever?
No, if the triangle is not a right angle triangle, so if you are in a position to say that these two are at right angles, then you could have done the two legs divided by 2 product. Is that clear to you?
Okay, yeah.
But if you're not sure, I'm just I'll just draw a line which is not making right angles here on a parabola, right? See, on a circle, semicircle, you get a right angle, but on a parabola, you may not get a right angle,
Yeah.
right? So do not assume. But if you could justify that this is at right angles, then you can use the legs. Perfect. But if you cannot justify that, in that case, you need to find the height. Well, there's another way also, which is Heron's formula you can use. Heron's formula can be used by just taking those 3 coordinate points and then do it. So for Heron's formula, you can look into my videos, how to apply Heron's formula. What is the formula indeed? Is that clear?
Yeah.
So that is another option. Perfect. So that was a great question. We had a very simple case where we could easily find the height, right? But if it is not so simple, in that case, as we took our case here, you need to find the perpendicular from the vertex to the base and then find its height, right? That will be a good exercise. So try examples like this, okay?
Okay, yeah.
Let's move on and take next question, which is question number 8. The equation y equals to 2x squared plus ax plus 23 can also be written as y equals to x minus 3 whole square plus b. Find the value of constants a and b. So that should not be difficult. It is again a completing the squares method, correct? Once you complete the squares, you can always compare the coefficients and get the answer. Correct, Amy?
Yeah.
So that should be. So you can try this on your own. So basically, you begin with y equals to 2x squared plus ax plus 23. Complete the squares as we had been always doing. So once you have this vertex form, you know both a and b, right? Correct?
Isn't that ax? Oh.
Yeah, when you complete the squares, in that case, you're getting an expression which is 2 times x plus a over 2 whole square minus a square over 2 plus 23. So the middle part, which is x minus 3, you can equate 3 as equals to a over 2, right? Find the value of a from there, which is 6 in this case. Once you have the value of a, then the second part of the second term is minus a square over 2 plus 23 equated to b. Substitute the value of 6 in a and find b, which is 5 in this case.
Just to double check, you know, with the first step, is it supposed to be ax or?
Where?
Like ax.
We took 2 common, so divide a by 2. Oh,
2x.
this is
Oh.
half a by 4, you mean, right?
Yeah, because,
Yeah, yeah, you're right. You're right. So this solution,
yeah,
yeah, you're right. So this solution is not quite right because uh, when you
a
took,
over 2 divided by 2.
so we have to take half of a, so it becomes a over 4, correct?
Mm-hmm.
So this should be, this is wrong. So it should be replaced by a over 4 whole square.
I'll do it, and
Yeah,
then I'll send it to you.
yeah, you do it. This is a over 4.
Okay.
You're right. So this is a over 4.
Yeah.
So in the result, this will be a over 4. However, this will be, yeah, you have to correct this. Sorry for that. That's the wrong solution.
No, that's all right.
A over 4.
I'll do
So
it.
A
I
over
was just
4,
checking.
yeah, you did the good correction. A is 3 times 4, which is 12. So this part will be A over 4. The outside part will be A over 4. When you do square of 4 will be 16, right? It will be 16. When you multiply it will be 8. So we have minus A square over 8 plus 23, and that is equals to B. When you plug in 2 here, so you get minus 144 over 8 plus 23 equals to B. You can now find B from here.
Mm-hmm.
So 2 times 8
You
times
did that quick.
4, 2, 8 times 2, 10, and 2, yeah, 8 times 3 is 24, 2, 8 times 2 is 16, and 2 is 18, minus 144 divided by 8, which is 40 by 8. Still you get the same thing? Oh, you get the same value of B. A value is 12 now. Okay, I hope that is the correct correction. So do it yourself, right? Redo.
Okay, yeah. Let me see if I get. Wait, so A is 12 and B is 5.
Anyway, yeah, take a
Okay.
picture. Then redo it and then
Okay.
we'll see, right? I hurriedly did some calculations. I hope they are correct. Then we'll see, okay?
Yeah.
Yeah, it looks okay. Let's take another question, which is question number 9. Find the range of values of
Mm-hmm.
k for which this equation, kx squared plus 2kx equals to 8x minus k, has two distinct roots. How will you do it?
So, like we said in the beginning, we use the discriminant, which
Yes,
is b squared minus 4ac.
correct.
So I'll just bring the 8 minus k to the left side. So that would be kx squared plus 2kx plus 8x. No, sorry, minus 8x plus k equals 0.
Correct.
Then we need b squared. So b, since the two, we bought like two stuff of x,
Yes,
but one being 2k and one being minus 8. So you have to take the value of b is going to be 2k minus 8
correct.
whole squared, then minus 4 times k times times k again.
Yes,
So you get 2k minus 8 whole squared minus 4k squared.
yes,
Yeah.
yes,
Being greater than 0.
correct.
Okay. Then you simply just expand. So
Yes.
use your grid, foil, any method you want, and then you solve. Should I
Correct.
just do it quickly here? I don't actually know how to do it in my head.
No, but that is okay. Well,
2k.
yeah. So what I did here was I factored this a square. This is like a square minus b square. Do you see that? So this is like a square minus b square. So I factored this as a plus b times a minus b, right? So the statement which I wrote
Oh.
in this particular step is not by expanding it, but by factoring it. So once I factored, I got the factored form. Do you see that? So I in fact factored, I never expanded using a square minus b square, which is a plus b times a minus b. So the first term is 2k minus 8 plus 2k, and the second term is 2k minus 8 minus 2k, right? I'm writing x there. A lot of typing errors with me. Okay, 2k. And when you combine the terms, 2k, 2k on the right side, they cancel and minus 8 remains. On the first factor, it is 4k minus, because 2k, 2k add up to 4k minus 8. Now that should be greater than 0, right? So since it is minus 8, I have to change the sign when I divide by minus 8. So I get
Right.
4k minus 8 is less than 0, and 4k is less than 8, and k is less than 2. So that is how I did using inequalities. Is that clear to you?
Yep.
So slightly different approach than what you could have taken, but your approach was also correct in this case. Perfectly fine.
I would never have thought of factoring
Yes.
like the factor. That's quite cool. Yeah.
Yes. So this is a new step, and the whole idea of making all this was that go with new steps and new strategies.
Mm,
Well, I know what strategies are known to you, right? So I try
yeah.
to get the alternate ways of solving the same questions in this particular video. That's the whole idea.
Yeah.
Now,
So far, all of yours have been quicker.
okay, question number 10. Can you please read this question and help me solve?
Yeah. So one of the x-intercept of the graph of y equals 3x to the power of 2/3. I think that's what it says.
Yes,
Yeah.
yes, yes.
Minus 5x to the power of a third plus k is at x equals to 1.
Correct.
Find the other x-intercept.
Yes. What will you do? Tell me. What is going to be your strategy?
Okay, so we got a point at x equals to 1.
Mm-hmm.
Oh wait, no, it's one of the x-intercepts. So we know that point is 1, 0.
Correct.
Can we sub it in?
Yes,
the
you can sub in.
equation?
Yes, yes.
Okay.
And find k. You know
Find
that point
k.
is 1, 0. Sub in and find k. So once you find k, you have the equation. And now it is the question of factoring the equation to find the second factor. Correct?
Oh, right, yeah.
Now this is factoring.
Oh, yeah, that's what I did.
Yeah, good.
Oh, yeah.
So now I used your strategy, substituting x to the power of 1 over 3 as u, right? Last time you were substituting x squared as y, correct?
Yeah.
So here, x cube root, I substituted as a variable u. So I got a quadratic equation. Once I have the quadratic equation, this is a simple one to factor. Factor this particular equation. As soon as you factor, one of the factor is u equals to 1. Well, u equals to 1 is already given to us as one of the x-intercepts. So it is the second one which we are looking into. So the second one is 3u minus 2, which gives us the value of u as 2 over 3. Substituting back x to the power of 1 over 3 as u equals to 2 over 3, we'll just cube both sides and find the answer, which is 8 over 27. How do you find that?
That was nice. I like when solutions work out well. Like questions like this where you can make, let's say, another variable, like let's say in this case x equals to a third, and then we're trying to find 2/3. Because it's so simple that you just need to square the other term, it works out really nicely. But it's when it's like not nice exponents, then that's when I don't like it.
That's so true.
Yeah.
That's so true. Correct. That is so true. So with that, we kind of end our session on this. Amy, can you summarize by saying, like, what did you learn in today's lesson?
All right, yeah. So I learned like a lot for starters. So you asked me like many different approaches to the way I would approach it, and then you obviously told me where I'm going wrong or where I'm taking up too much time, or where some strategies are actually quite good. So so like we went through 10 questions covering a variety of kind of all the content that could come under quadratic functions. So I could just quickly go through a summary of all of them.
Sure.
Just what I learned.
Yeah.
So with isolating the variable, seems really easy, but obviously, as you can see, you can't simply take out t like that. So what we did was completing the square. That was a very prominent method that we use kind of throughout all the 10 questions. It is a long process, but for some of them, that's kind of the only process. So especially with isolating the variable, I think that's even though it's a little bit long, it is the one to use because that's the only way to kind of isolate t.
Agreed.
About transformations, so what I learned in that was you complete the square, but the form that you get in the end, you have to do the transformation in order. So you have to start from left to right. You start with the coefficient, let's say the vertical stretch, the compression, then the horizontal translations, then the vertical movements up or down. It has to be in that order.
Yes.
Then 3, with this one, again, we did completing the square. I did by taking the constant c to the other side, but the process is still the same. Just keep c away. Yeah, that's a key.
Okay.
Oh yeah, so 4, this is where it was like game changing. So yeah, with this one, you complete the square, or you can do the whole discriminant thing that I did. But whichever method you use, don't just stop at the kind of the method. You have to justify your answer. So like I did when I said the whole b squared thing, I just said it doesn't cut the x-intercept, therefore it's always positive. That's not correct at all, because that's not necessarily the case, because you can have it the other way around, you can have it in different positions. So you have to use what the question is giving you to help justify, and it's all there in the question. So saying it's always positive, you can clearly see the coefficient is 1, it's positive, so it's going to be concave up like this, and we can clearly see the y-intercepts at 10, which is a positive number, so therefore always positive. So you always justify. 5, factoring, yeah, so that's when I did just make y equals to x squared, because you can see a relation between x squared and x to the power of 4, so you can use that, nice and simple. The product of 2 consecutive even integers, oh yeah, so this is where I tried to complicate myself, and then you said obviously keep it simple, so just simply work with x and x plus 2. So the question I asked was, how do you know x is even or odd? And what you said was, let's start by never assume in maths, but you might as well start with this one assuming it's even, because even if you work through it and you get to the answer, you didn't do any time wasting, because like you said when I asked you that question, the question they're asking us is to find the possible integers. They're not asking us to justify whether x is even or odd, or if it's consecutive, none of that. So just keep it simple.
Yes.
Question 7, line intersects the parabola. Oh yeah, so these triangle questions. So yeah, when you create your triangle, always make a rough, quick sketch. So most of the points are in the question, so you've got your turning points, you can easily find the intercepts and things. Make your sketch, draw the triangle out, and always find, I think the safe bet is finding their height, because you can always just do, let's say you have a line like this, finding the height, if it cuts across that, just find the reciprocal negative like that and work like that. Or you can watch through Sir's videos on Heron's formula, so you can look at that. I need to do that. I keep saying I need to, but I know I need to do that, yeah. Then finding the range of values of k, yeah, so clearly it states 2 distinct roots, so when you see that, you know you have to use the discriminant, and it has to be greater than 0. Yep, and then 10, again, this is like question 5, it's finding that relation between the exponents, so we can clearly make any variable. Oh yeah, but yes, before you do that, we have been given additional information saying x equals to 1, but we know that that's the intercept, so we know that's a point. 1, 0 is a point that they've given us, so just sub that in, find k, and then do the rest of the things that you said.
That was perfect. So you got it all. So we'll take up the next unit review, which is surds. And once we do that, we'll actually take a cumulative review of a line quadratic function. And in that, I'll take up an example where we'll find the area where it will not be a right angle triangle.
Straightforward.
That will force you to do Heron's formula in that case.
Oh no. Okay, I need to start watching those videos.
But that was great. I hope you learned about it, all this.
Yes, I did, a lot.
That's great.
Thank you.
So see you next time on this particular review, and do all the questions from your textbook.
Yes, thank you so much, sir. This was so helpful. Thank you.
Bye.
Bye.